Hello, math students. Welcome back to Module 3, Expressions and Equations. This is Lesson 3, and it is called Writing Products as Sums and Sums as Products. Our goal for today we are going to learn how to apply the distributive property and undo the distributive property. The question that I want you to think about during this lesson is, what number can you multiply by anything and the answer is the number's opposite? What number can you multiply by anything, and the answer is the number's opposite? So hopefully by the end of the lesson you'll be able to figure that one out. Things to remember. Let's do a quick review. In 6th grade you learned about using tape diagrams to help you solve problems, so let's take a jog down memory lane and see what you remember. A sum of money was shared between George and Ben in a ratio of 3 to 4. If the sum of money was $56, how much did George get? Use a tape diagram to solve. So a sum of money is shared between George and Ben in a ratio of 3 to 4. So for every 3 that George has, Ben has 4. If the sum of the money was 56, so that means all of their money added up together equals 56, how much did George get? Okay, so if we're looking at our tape diagrams, we know that George is represented by 3 sections of tape diagram, and Ben is represented by 4 sections of a tape diagram. So if the whole thing combined is $56, then we know that all we have to do is we have to take 56 and divide it by how many sections we see. So 56 divided by 1, 2, 3, 4, 5, 6, 7. If we take 56 and divide it by 7, then we know what goes in each section. So if you have 56 divided by 7, then the answer is 8. So we know that 8 goes in each section of the tape because this is what you learned in 6th grade. Okay, so then we can take a look at it and we can figure out from looking at what tape represents George, we see the top tape represents George and there are 3 8s. So then I have to take 8 times 3, and I know that 8 times 3 is 24, so that means that George has $24. And you were able to figure that out by that quick review. Okay, so now let's check out another one. Check this out. If you don't know what something is, you are allowed to, instead of putting a number in the tape diagram, you're allowed to put a value in there. So if we don't know what the answer is that goes in here, we can call that X. And so it says, what does the rectangle labeled X represent? The rectangle labeled X represents the unknown amount of money. And so what we could say is we could take this whole amount right here, like it said up above, was worth $56. So then you could say that we have 7 times X equals 56. And so you can look at it as a multiplication problem as well. So what number times 7 gives you 56? Well, if you know your math facts, then you know the X has to be $8 because 8 times 7 equals 56. So you can solve it 2 ways. You can either solve it by counting how many you have and divide by that number, or you can set it up as a multiplication problem where you say what number times 7 equals 56, and it can be represented both ways. All right, so then the next thing that we have is, now can you represent 3 plus 2 using a tape diagram? And everybody in this class should be able to say, yes, I can, because this is a review. So if I have 3 plus 2 in a tape, I'm going to draw a tape, and I know that I have 3 right here, and I have 2 right here, and that's how you would represent 3 plus 2, because a tape means anything that's in the same tape gets added together. So these 3 8s got added together. 8 plus 8 is 16, plus 8 is 24. 8 plus 8 is 16, plus 8 is 24, plus 8 is 32. So anything that sits inside the tape, it means it's added together. So I have 3 plus 2, and this is what the tape would look like. Okay, 3 plus 2. So yes, we can represent that using a tape diagram. So then the next thing we have to talk about is, can you represent X plus 2 in a tape? And the answer again is yes. Change the color so you guys can see. Let's go with this color. So again, we draw a tape, right? And we know that according to this one, it has two sections. And one of the sections is going to be x, and one of the sections is going to be 2. So I know that x plus 2 can be represented in a tape by looking like this, x plus 2. Okay, so that's the other way you can show it in a tape. So now, if we're going to keep thinking about what we've been learning, we learned how to show 3 plus 2 as a tape. We learned how to show x plus 2 as a tape, and now it's asking us to do the next step. How would we use a tape diagram to show 3 groups of 3 plus 2? Okay, well that's not hard, because remember, this number right here tells you number of tapes, right? And then what's inside of here tells you what goes inside the tape. Okay, so if we write it out, we know that we need 3 tapes. So I'm going to draw 3 tapes. So here's 1, here's 2, and here's 3, because remember, that number tells me how many I need. And then I have 3 plus 2. So 3 and 2, 3 and 2, 3 and 2. So there we go. We have 3 plus 2s. Okay? All right, so now it's asking you to do the next one, which says, can you show 3 tapes of x plus 2? So again, remember, the number outside tells you the number of tapes, and then the amount inside the parentheses tells you what goes inside the tape. Okay? So again, I need 3 tapes. So here we have 1, 2, 3 tapes. And then inside it, I need to have an x plus 2, an x plus 2, and an x plus 2. All right, so I did 3 tapes of x plus 2s. Okay, well that's not difficult. So now I'm going to take the next challenge, and it says, using what you know about area, what would be the area represented by the sections of the tape diagrams from above? Okay, so let's try it. I'm going to draw the tape diagrams that we had above. I'm going to use a different color this time so that you can see it. So we had 1, 2, 3, right? And inside those, we had 3, 2, 3, 2, 3, 2, right? And now it's asking us to determine what is the area that is represented by the sections of the tapes from above. So the sections, how did I get this 3 inside? Well, if I look at it, I have 1, 3, right? And so if I'm taking area, remember area means length times width, right? So if I have 1, 2, 3 threes, the length on this one is what? 3, right? And then the width of this one is 3 plus 2. So that's the width. Okay? So I have 3 plus 2 up here. And so when I get that, 3 plus 2, watch what happens. What is 3 times 3? 9. What is 3 times 2? 6. And then they're being added. Well, now let's count and see what's inside, because remember, area is what is inside. Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh my goodness! If we took all of these, because they're inside, we get 9. If we take all of these, because they're inside, what do we get? 6. So the area model works just like it does when you have length times width. So remember, when we're finding area, we are taking the length times the width. So the length is 3, because there's 1, 2, 3. The width is 3 plus 2, because that's what's happening in our tapes. And then that means 3 times 3 equals 9. 3 times 2 equals 6, and they're being added together. 1, 2, 3, 4, 5, 6, 7, 8, 9, same number. 1, 2, 3, 4, 5, 6, same number. So I have 9 plus 6. Okay? So that was pretty cool. All right. So what do we have to do for the next one? Because remember, we were supposed to do it for both. So we take, I'm going to actually draw it down here, and then we'll talk about it. So we had 1, 2, 3 tapes from above, and this time inside them we had x plus 2, x plus 2, and x plus 2. What is the length? 1, 2, 3. So I have the length is 3. What is the width? I have x plus 2. So remember how you find area. How do we find area one more time? We take the length times the width. Okay, so here's the length. I have 3 times x gives me 3x plus 3 times 2, which gives me 6. So now let's check it and see if it worked. 1, 2, 3 x's. I see 3 x's on the inside. There it is. Okay. I see 3 2's. 1, 2, 3, 4, 5, 6. Aha! I see plus 6 right there. So the area model works. You took the length times the width. The length times the width. The length times the width. Okay? And so that's another way to find out how to figure out the answer by using the area model or by using the tape models to help us figure it out. Okay? All right, so that was kind of cool. Now let's look at this next one and see if it's coming together for you yet. So you applied the distributive property. The distributive property states that you multiply the coefficient by all of the terms of the expression inside the parentheses. That's exactly what we did. This is the coefficient. We're multiplying it by everything inside. Factored form tells you that you need to apply the distributive property. So when it looks like this, what we're supposed to do is we're supposed to distribute the 11 to the 7 and the 11 to the 4. Okay? And if you look at our tapes, I've already done that for you. So it says, remember, the coefficient, the number that sits outside, tells you the number of tapes, right? And then the amount inside the parentheses tells you what goes inside the tape. Okay, so let's check it out. So we need 11 of them. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to draw one more because we're supposed to have 11 tapes. So let me draw one more. That was my fault. When I was making these, apparently I forgot to put one more. So I'll just add it in there and then we'll be good to go, right? Okay, so now I have 11 of them. And inside, I'm supposed to have 7. So all of this together, the shaded part, that shows us that I have 7. The gray, or the ones I'm coloring right now, those represent 7. And then the white ones represent the 4. Okay, so all of this is 7. So from here to here is 7, right? And that goes all the way down. 7, 7, 7, 7, 7, 7, all the way down. 7, 7, all the way down. 7, and last one, you can barely see it, sorry, 7. Okay, so those all have 7. Then these over here represent 4. Count them. 1, 2, 3, 4. So these are 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. So now what I have to do is I have two options. The first one that I can remember is I have 11 sevens. So that means I'm going to take 11 times 7, and that gives me 77. And then I'm going to take 11 times 4, and that's going to give me 44. And that is what we see in front of us. But if you also want to do the area model, remember what you did. You did length times width. So we know that my length right here, all the way down to here, is 11. And I know my width is 7 plus 4. Again, remember how we did that before. So now I'm going to count them. Ready? 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77. So if I add all of these up together, then I count them, I got 77 plus, count these over here, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. And that's where those come from. And then we've got the same answer either way. So this one, we distributed it. Remember, we did 11 times 7. 11 times 7 is 77, and 11 times 4 is 44. Okay, so now I have 77 plus 44. Or I can do it the area model where you take the length times the width. So you count what's inside, and we did that. We got 77. You count what's inside, and we got 44. And that's how you determine that the answer of the distributive property is like that. So again, the distributive property means that you take the number, the coefficient that sits outside, and you multiply it by each term. That's what we did right here. The area model says that you tell us what is inside. So 7, 7, 7, 7, 7, 11 times is 77. 4, 4, 4, 4, 11 times is 44. And that's how you come up with that one. Okay, so it says, what is the area of the gray section? The area of the gray section was 77. What is the area of the white section? 44. What is the total area of both sections together? And we haven't actually done this yet because I was waiting for that question. All together, that now means you add them together. So 4 plus 7 is 11. Regroup the 1. 4 plus 7 is 11 plus 1 is 12. So I got 121 when I added them together. Let's try it over here. 7 plus 4 is 11, right? Regroup the 1. 4 plus 7 is 11 plus 1 more is 12. So now I have 121. So what is the total area of both sections together? The answer is 121. And you use the distributive property or you use the area model. Either one will work every single time. Okay? All right, kiddos. And now we have one last side. So let me turn this one over. And we're going to see what we have to do for the back side. Use tape diagrams to see what each problem looks like. Okay, so this is going to be different, but it'll be fun. So we have to draw a tape, and the amount, remember, what's inside the parenthesis is what the tape looks like, and then how many do I have? I have 3. So that means I have to draw 3 tapes, 1, 2, 3, because I have 1, 2, 3, and then inside the parentheses goes inside the tape. So X and Y, X and Y, X and Y. Okay, so then how many X's do you see? 3 X's plus how many Y's do you see? 3 Y's, and that's what I get to have for that expression. Okay, so now let's try this one. I have 2 tapes, right? 2 tapes, and inside this tape I have 3 X's, right? And inside this tape I have 3 Y's. So what does this answer come out to? I have 3 X's plus 3 Y's. Interesting. Okay, so now the last one that I have to do is it says that I have 3 X's plus 3 Y's. Okay, so I have one tape that shows that. One tape, and I need 1, 2, 3 X's, X, 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 plus 1, 2, 3 Y's. And that's what that tape would look like, okay? And if you look at it very carefully, we actually did the exact same problem 3 different ways because I have 3 X's here, I have 3 X's here, and I have 3 X's here. I have 3 Y's here, I have 3 Y's here, and I have 3 Y's here, okay? So it's actually all the same problem every single time, but it's just drawn differently according to how they set it up to begin with, okay? So that's kind of cool. The final answer after distributing the coefficient is called standard form. So, how many tapes did I have? 3. What was inside the tape? X plus Y. And now I'm going to find standard form. Well, if I take it from factored form to expanded form looks like this. Remember, we just talked about this in class on our test. And then the next form that we do is standard form, which is 3x plus 3y. Okay, and now you've written it all 3 ways. So this is factored form, right? This is expanded form, and this is standard form, just like we talked about in class the other day. All right, so that's kind of cool. How do you take standard form and turn it into factored form? Well, this is the part where we talk about undoing the distributive property. And if you remember in class, we talked about this a little bit, and what we had to do is we had to find the GCF. I hope that's ringing a bell for all of you. So we're going to find the GCF. If we have 8x plus 4, what I want you to think is, what do both terms have in common? What does it mean to factor something out? Well, what you're going to do is you're going to find the GCF for 8 and 4. Okay, so that's not too bad. I know that 1 times 8 equals 8, 2 times 4 equals 8, and so now I found all the factors of 8. I know that 1 times 4 equals 4, and 2 times 2 equals 4, so now I found all the factors of those. So now I have to find the greatest one they have in common because it's the greatest common factor, and the greatest that they have in common is 4. 4 becomes your coefficient that sits outside. So the 4 goes right there. And now I don't just get to take this and write it in there. Okay? I actually have to factor it out. That means I divide it off of both terms. So what is 8x divided by 4? 2x. Okay? What is 4 divided by 4? 1. So that is how you undo the distributive property. Now watch, this is really cool. This is how you check it to see if you were right. How many tapes do I need? 4. 1, 2, 3, 4, right there, yeah. And then what goes inside the tape? 2x, 1, 2x, 1, 2x, 1, 2x, 1. Now count what you have. 2, 4, 6, 8. I have 8 x's plus 1, 2, 3, 4. Ah, does it match? It absolutely does, so you know you did it right. Okay? So this is called undoing distributive property, and then these up here and everything that we've been working on through this whole lesson is actually doing the distributive property. Okay? So now I have 3 problems for you to try without me. The first thing I want you to do is find the GCF for all 3 of them. So GCF, 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 right? Okay, then the next thing that we did is when you find the GCF, it sits on the outside, and then you have to divide it off. So I want you to remember what we did right here, and I want you to try it for those 3 additional problems. Okay, kiddos? All right, that was the whole lesson. Let's go back to our goal. Today we are going to learn how to apply the distributive property and undo the distributive property, which we just did. What number can you multiply by anything? And the answer is the number's opposite. Okay, well, let's try it. One thing that I do know, what number can you multiply by anything and you get that answer has to be 1. But if I want the number's opposite, then 1 times 7, I'm going to get 7. 1 times 23, I'm going to get 23. What happens if I do negative 1? What if I do negative 1 times 7? Well, I know 1 times 7 is 7, but I know a negative times a positive. If I use my little helper tool, a negative times a positive gives me a negative answer. Boys and girls, is negative 7 the opposite of 7? Yes, you just figured it out. So what number can you multiply by anything and get an answer of the number's opposite? The answer is negative 1. All right? You want to keep that as future information for you to use. All right, kiddos, that's all I have for you today.